Welcome guys to this video about drag and drop items in Jetpack Compose. So in this video I will show you how you can build such draggable items as you can see in this little example app here. You can press on them, they get copied, and then you can drag them around and place them inside this drag destination. And if I let go now, then the person gets added, as you can see. I can also add another person, and if I don't hit this rectangle in the middle, then just nothing happens. This draggable and droppable items don't have to be rectangles with person names in the middle. I will show you a generic way how you can make anything draggable and droppable and also pass any kind of values to your drop destination. Alright, okay, I'm in an empty Jetpack Compose project here, and first of all let's create our drag and drop logic. So in our root package we can create a new Kotlin file called drag and drop. And first of all, we need to define our possible states for our drag target, which will be in our case the rectangle we can drag to a specific drop destination. So we can make this an internal class drag target info. And in here we will have some different drag state variables so that we always know what's currently going on. First we will have is dragging of type bool by mutable state of, which is false by default. We need to import that, and then the drag positioner also by mutable state of, which is offset.0 by default. Then the drag offset by mutable state of, which is also offset.0 by default. We will also have a draggable composable because if we want to drag and drop something, then we want to copy the composable. We don't just want to drag it away from its initial position. We want to copy it and drag around the copy of our selected item by mutable state of. And now I need to care of the syntax. This will be a composable, which returns nothing and is optional and null by default, like this. And then we will also have some data to drop, because if we drag and drop the item and drop it into the destination, into the rectangle destination, then we also want to pass some data to, for example, a Viewmodel to process this data by mutable state of type any, which is also null by default. Now we want to define our drag target composable, which will be the most complicated one in this video here, but let's just finish this right away and things will get easier after that. So this will be a composable drag target, and this drag target will take a modifier, which is the default modifier by default. We have some data to drop of type T. We will make this a generic type. We need to take this T in front of our drag target definition here. And then we will also take a view model, but let's add this view model later on, because right now we will just focus on the composable. And this drag target will take a content which is of type composable and does not return anything. And in here, in our drag target, we will have the current positioner by remember, mutable state of. The offset will be 0 by default. Let's import remember. Then we also need our current state of the drag target, which we get from a local drag target info content provider, which we will define up here. This will be an internal val. Local drag target info is equal to composition local of our drag target info, and we get all the default values by the default here if we get this local drag target info from our provider here. Then we will also have a box which takes the past modifier, and we need to get the position of our drag target, because this initial positioner is used to calculate the new positioner, because when we get all these drag changes, then we can add them to the current positioner and then we get the right dragged positioner. So we can get this from on globally positioned, and here we can say current position is equal to it dot local to window, and we need to pass an offset here, which is offset.0. Then we can also use a pointer input for the drag gestures, And in here we can then define the logic for the long press gestures, because we don't want to make such a track target available to the user after every click. We want to make it just available if the user does a long press on the track item. And first of all, we need to define the detect track gestures after long press here, this one, and we then can take the argument list with all those lambda functions. We will start with onTrack start here. And when the user starts dragging, then we can update our view model. We will do this later. I just annotate this here as a reminder. Viewmodel.start tracking. Then we can update our current state dot data to drop is equal to our past data to drop of generic type t. Then the current state dot is dragging is set to true. The current state dot track position is our current position plus it. And we also set the draggable composable here to our content, because we want to copy the composable, the drag target, so that the initial target gets stayed on the initial position, and our drag target now is our copied target. So we can just drag it around the screen and see the copied version of it. Now we will take care of the onTrack lambda. So let me scroll up a bit. And in here, we will get the change and the drag amount. And for the change, we can just say change.consume all changes. And then we can update our current state, track offset, and add the offset of our drag amount .x and drag amount .y. And this will be offset. And after that, we can then take care of the onTrack end. And here we can say Viewmodel.stop dragging, which we will also implement later. And then we can say our current state drag offset is equal to offset.0 again. And the current state dot is dragging is equal to false. And the same thing for our onTrack cancel. So we can just copy and paste these values here. And then inside our box, we will have the content. So this is the original content. And as I've already mentioned, the same content is used for our draggable composable for the copied version, which we can then drag around the screen. Alright, okay, let's take a little recap at our track target composable here. So this composable is just kind of a wrapper composable around some content we pass into. So later on when we use this, we will say track target and open the curly braces, and in here we can pass columns, boxes and all that stuff. And everything that is in this curly braces is then draggable and can be dragged around the screen. And in addition to that, we can also pass some data to drop of type t. So this t is a generic type, so we can pass anything we want, so any objects we want. And this data to drop can then be used to drop to the destination and can be processed then if the track item is in the right track destination. And all the calculation for the draggable item, where its current position and where it should be shown in the UI, is done here. And here we also set the current state here and down here. And this current state can be then observed inside a drop item, and then the drop item can detect, oh, the track item is in the right range to get dropped. So I can blink up and show the user, this is the right destination, you can let go now and you can drop it now. And now it's actually time to define this drop item composable down here, which will be of generic type t, and can take a modifier here. And also it's a wrapper around the content of another composable, like the track target was. And this composable here will provide some information. So one information will be if the track item is inbound. So if the track item got dropped at the right location, and also optionally the data. So if it is inbound, then we will also provide the data. So we can here say boxscope.is inbound of type Boolean and also data of type t, which is optional. and this will return unit as always. And in here, in our drop item, we can then get the current track info. So well track info is equal to our local track info dot current. So we get the current track info of our track targets. Then the track positioner is equal to our track info dot track positioner, and the track offset is equal to track info dot track offset. And we also need a var which is indicating if the current track item is on top of the drop item and is ready to get dropped to the right destination. So we will call this is current drop target, and this is by remember and false by default. And then we can check on this. So the drop item will be also inside a box which takes a modifier, and in here we can then say, oh no, let's take our past modifier here, and then we can say on globally positioned again, and it's dot bounce in window dot let, and there we get a rectangle, and then we can check if this rectangle is containing our track target. We can say is current drop target is equal to rect.contains, and then our track position, which is kind of the started track position of our track target, so the position where the track started, and then our track offset, the position where our trackable item got tracked to. And if this rect contains this offset here, then we know that the track item is on top of our drop item or in the bounds of our drop item. But we also need to know if the user actually dropped the item at the right place or if he just hovered over the right place and didn't let his finger go. And depending on that, we will provide the data differently. So we can say val data is equal to if is current drop target, so the track item is on top or in range of our drop item. And in addition to that, if the user is currently not tracking, so that means he really dropped it at the right place. And then we can provide our data to drop as our generic type T, or else we pass null. And then we can invoke our content composable here. So this composable, which will be the composable you will provide or you will show the user in the UI where he should drop the item into. So this will be our is current drop target for the information if it's actually inbound. And in addition to that, our data. And later, if we use this drop item, then we can just say drop item, something like this. And in here, we will get our is inbound and our data. And then we can check on this if it's inbound and change the UI. So make the drop item place blink to the user so that he's aware of that the item can be dropped now. And also the data, if it's actually dropped and if it's inbound, then the data is not null, and then we can pass it to a view model for some processing or something like this. All right, okay, that's actually it for our drop item. And now we need to define our draggable screen as the last part of our drag and drop file here. And then we can build the UI, and you will see how easy it is to use these components. Our draggable screen will be also composable, which takes a modifier, which will be the default modifier by default. And the content will be also composable, so our draggable screen is in the end just a wrapper around our normal screen and makes it possible to drag and drop items or to animate them and scale them so they will become bigger and all that things. So the draggable screen will listen to some track state changes and react depending on that. So this will has a box scope and returns unit as always. And then in here we will have val state is equal to remember, and this will be our track target info. And in here we need our current tracking state of our tracking items, so we can say composition local provider, and we don't pass the context here. Instead of, we will take the local track target info provides state, And in here we will have a box which takes our modifier and say fill max size. And in this box we will first invoke our content. So this will be our normal screen here, this content we pass up here in our trackable screen because it's also kind of a wrapper here. And then below this content we can check if the user is currently tracking from our tracking state. And if this is the case, we can define a target size by remember, which will be a mutable state of and insize.0 by default. And then we will define another box which takes a modifier, .modifier, and this modifier will have a graphics layer. And in this graphics layer, we then define the logic to increase our track item size. So if we drag it, then it pops out to the user and it will be a little bit bigger than the initial one so that we can see that it's really the track item here. And to show you how this works, we will first define the box content. In the box content, we will invoke from our state the draggable composable. So here will the copy come into play. So we have the copy of our draggable composable inside this variable here, and here we can say, because it's of type optional, we need this question mark, we can say invoke. So we will invoke this composable to show up in the UI, so the copy gets showed up in the UI, and inside this graphics layer we now need to define the logic that it's a little bit bigger than the initial one. So how we can achieve this, we will first need the offset is equal to state.trackPositioner plus state.trackOffset, and then we will have a scale x is equal to 1.3f. This is my value here. I choose this because I think it looks good. You can easily take another value here. Scale y will be also 1.3f, and then the alpha, the color alpha is equal to if target size is equal to insize.0, so the initial value here, then it will be 0f, and else it will be 0.9f. So it will be a little bit more transparent than the initial one. And if the item is not tracked at the moment, then this target size is insize.0, then it will be 0f, so it won't be visible at all. And then we have a translation x, which is equal to offset dot x dot minus target size dot width divided by 2, because we want to start in the middle of the x coordinate of our target, and the same for our y, because then the transition is equally in all directions. And then we can also say on globally positions, and our target size will be equal to its dot size. And I think this is it for our draggable screen component. And now we can start building the UI and use this drag and drop components. And let me first fix this little error here. This is not the width, it's the height, of course. So always be careful with copy and pasting stuff. So let's create a data class first for our UI, which will be a person UI item. So this data class will be very simple. So this is just to show you that you can pass around objects and not just primitive types with this drag and drop logic, with this generic type T. And this person will also have an ID and a background color of type color, the compose one here. And then we can go to our root package and create a new Kotlin file, which will be our main screen. In here we will have our main view model, which we will define now. So in our root package, new Kotlin class, main view model, this will inherit from Viewmodel. And in this Viewmodel, there are some states. So if the user is currently dragging, if he's not dragging, and the logic for adding a player, keeping the current added player list and all that stuff. So I don't want to do this in the UI. So let me quickly implement this in a little Viewmodel here. In here we have the state var is currently dragging by mutable state of, which is false by default. We make this a private set because we only want to change this variable inside the view model. Then we have some person items, mutable state of, empty list of type person UI item. And we can also make this a private set. And then we have also our list of the added person. So var added persons is equal to mutable state list of type person UI item, and we can make this a private set as well. And then in our init block of the view model, we will initialize our items. Items is equal to list of person UI item. The ID will be 1 and the color will be gray. And then we can copy and paste this like this. And the second name will be Larissa, the third Mark with ID 3. And the color will be blue here and the color will be green for Mark. And it doesn't matter if we initialize this list here or on the top here. And yeah, well, this should be rather simple here and don't be overthought. So then we will have a func start dragging, which will initialize or set our currently dragging state to true. Then we will have a func stop dragging, which will set our state to false. And then we have another function for adding a person, which we can call from the UI. So person UI item, and then we can say added persons dot add person UI item. And that's it for our view model. Now we can start building the UI, and then we are good to go to test this out and adding some persons with our drag and drop functionality. In our UI in the main screen, we will first have our screen width, because then we can make our player items depending on this width and don't have to use total values, but you can of course also use total values. And this doesn't matter here, the UI will be really simple. And then we have a column with a modifier which fills the max size. The vertical arrangement will be arrangement.spaced by 50 dp, and the horizontal alignment will be center horizontally. And in this column we will have a row which also takes a modifier. Let's import the row here, and this modifier fills the max width, has a little padding of 20 dp, and the vertical alignment will be alignment.center vertically, and the horizontal arrangement will be arrangement.space between, so that the row items, our person items, get spaced evenly and get pushed to the sides, to the left and the right side. Inside this row we can say main view model .items .for each, and here we get our persons, and for each person we will have a drag target. So now our drag target from our drag and drop logic comes into play, and this drag target has some data to drop, and this data to drop are just simply our person data, so our person UI item. And then the generic type T will be of type person UI item. Then we will also pass a view model, which will be our main view model. Let's just go to our drag target and adjust it. So in here we will have view model of type main view model, and now we can uncomment these lines here, because then we can say view model dot start dragging, so that we are aware of dragging, and depending on this we can do something from the view model, or accessing this state and asking if it's currently dragging. And then we can also here uncomment this and uncomment this, so we are always aware of the dragging states if the user is currently dragging in our view model. And in our main screen we can then ask our view model, if the user is currently dragging, then show the drop item, then slide in this drop item, because otherwise we don't need to show this drop item. And for the content of our drag target we will pass a box which takes a modifier. Dot size will be dp of our screen width divided by 5f, and as I already said, you can choose your own values here, and you can also pass any kind of content here inside this drag target, because we defined it has just to be a composable. And then this box will also have a clip with a rounded corner shape of 15 dp, a shadow of 50p, and with a rounded corner shape of 50 dp as well. The background will be our person.background color and will also have a rounded corner shape of 15 dp here. And the content alignment of this box, so that the name of the player gets centered in the middle, will be alignment.center. And now we can define a text in here, import text. The text will be person.name. The style will be material theme.typography.body1. The color will be color.white. And the font weight will be font weight.semibold. And now we can define our drop item where the user can drag the person items into, and we will make this an animated visibility because we don't want to just show this up if the user is currently dragging. We want to make this slide in horizontally so that it looks a little bit more smoothly. And this animated visibility should only show up if our user is currently dragging. So if our main view model has the state that the user is currently dragging, which it gets from our drag target. And the enter animation will be slide in horizontally, and the initial offset will be it. And in this animated visibility, we can then define our drop item. So drop item, which is of type person UI item, our generic type will be here the person UI item. It takes the modifier, which will be modifier.size and dp screen width divided by 3.5f, so that the drop item is a little bit larger than our drag items, because the drag item also gets increased by size. If it's currently dragging, it gets multiplied by 1.3 we defined earlier. And in here, the drop item, we then get the values we are interested in. So we get, on the one hand, is in bound, and depending on this is in bound variable, we can then make the drop item look or blink up if the user really drags over the drop item and is in the right range. And then we get also the data, so our person UI item, to pass it to the view model if the user actually dropped this item. And this data will be always null. Just if the user dropped the item, it won't be null anymore, and we can check on this and enter some logic for it. So if person item, oh no, let's call this person item here. If person item is not equal to null, and this is just the case if the user dropped the item. So we don't need to check if it's in bound, because the person item is just not null if the user actually really dropped it. Then we can execute a launched effect here, and the k will be our person item. And in here we can say main view model dot add person, and we will add our person item here. And now we can define how our drop item will look like. So we will make this depend on the is in bound boolean. So if is in bound, then we wanna make it blink, so the user is aware that it's in the right range. This will be a box which takes a modifier, fill max size, and we will give this a border of 1 dp. The color will be color.red, and the shape will be rounded corner shape with 50 dp corners. Then we will also have a background, which will be color.gray.copy 0.5f, so it won't be that gray. And this will also have a rounded corner shape of 15 dp. And then we will also have the content alignment, which will be alignment.center, because inside this box we will show a text so that the user can see what's actually happening if he drag and drops this target into the destination. So add person, the style will be material theme.typography.body1, and the color will be color.black. And if we are not in this case, then we will go into the else case. So if the user is currently dragging, but the item is not in bound, then we will show the box differently. And in a real production app, I would make this reusable, composable, but for the sake of simplicity, we can just copy and paste this here and change some color values here. So for the border, I will choose color.white, and also the background will be a little bit darker with color.dark, no, not dark, black, and we can increase the alpha of this color a little bit here. All right, I think we can already try this out. Let's go to our main activity and remove this default stuff here, also the preview. And then we can say draggable screen, which takes a modifier, modifier is equal to modifier.fillMaxSize, and our background will be color.black.copy 0.8f. And in our draggable screen, we can then pass our content, our actual screen, so our main screen. And we also need to define the view model here. I will do this up here, private val, main view model. In a real world application, I would also use some kind of dependency injection framework here, but let's just define it like this, and then we can pass it down here. So main view model, and then we can start the application. All right, let's try to drag and drop something. So I will choose this person, and as you can see, it gets copied. The composable gets copied and increased by size. And then we can drag it around and hover it over our drop item here, which blinks if the drag item is inbound. So the is inbound functionality works also quite well. And yeah, we can then drop it, then nothing happens because we didn't define a logic here for showing the added players. We just add them inside our view model. But yeah, this looks like it's working really well. We can track everything here and drop it in our drop item. And yeah, the font color here is not that good for the add person. We can change this to white, I think. And yeah, let's quickly do this. And then we will also implement the logic for showing the added players. So in here, we will change this to color.white. I think when we did hover over it, then it looked okay with the color.black here. But yeah, let's just quickly try this out. Yeah, I think this looks better now. All right, okay, then the last step we want to do is to define our list where the added players are shown. So this will be a box which takes a modifier .fillMaxSize. The padding will be 30 dp, and the content alignment will be alignment.center. And inside this box we will have a column which also takes a modifier.fillMaxWidth. The padding will be 20 dp. The padding for the bottom will be 100 dp. The horizontal alignment will be alignment.start, and the vertical arrangement will be arrangement.spaceBy 10 dp. And in this column we will have our added persons. So first of all, we have a general text, added persons. The color will be color.white. Style will be materialtheme.typography.h6. The font weight will be bold. The modifier will be modifier.fillMaxWidth, so that we can align the text to the start. Text align will be start. And below this text, we can then check on our added players. So main view model, added persons. For each person, I noticed that I always say players, but I mean persons here. Text will be the person.name. The color will be color.white. Style will be materialtheme.typography.h6 as well. And the font weight will be bold. And now we can try this out. Okay, let's add some persons. And as you can see, they get listed down below. Feel free to make this a better looking list here, because this is really crappy what I did. But I think this shows the point to list up the added person and to work with the person items from a view model after drag and drop then. And you could also implement some kind of logic that a person can only get added once, or increase some kind of counter or something like this. Alright, okay, thank you for watching this video. I hope you enjoyed this and you learned something about draggable and droppable items in Jetpack Compose. Feel free to make your own items and your own composables, draggable and droppable. And yeah, let's see us in the next video.